Hello everyone, and welcome to the 8.1 notes. This is going to be part one of this little video series where we're going to be introducing the idea of sequences and series. And I say introducing because we're not going to get too deep into this topic. Of course, this is a gigantic topic. We could spend so much time on it. But we just want to, at the beginning here, define what does it mean, a sequence. In a sequence, you may have seen them before. You can write down sequences, which would just be lists of numbers, basically like 1, 2, 3, 4, going like this. This is a sequence. If we stop the sequence there, we just say the sequence goes 1, 2, 3, 4. That would be something that's called a finite sequence. And so finite is the opposite of infinite. We're here a finite sequence. That is a function where the domain is just a certain group of positive integers. We'd say the first n of them. So here, since there are 4 numbers, we'd say n is equal to 4. And our function, you notice we plug in a number into the function. Here, instead of calling it f of x, it's kind of conventional to call it f of n because we're just plugging in integers in here. X should most of the time be real numbers, but then n, it kind of makes sense to have them as integers. Where integers, if you can remember, I would just make mention integers, especially positive integers. They're the numbers that go 1, 2, 3 like this, going up into infinity. Those are positive integers. And so here we make a function where we're going to define the term of the sequence, what is the value that's there, based on which term it is. So for example, this number is the first term, so this should go whenever n is 1. This is like the second term, this is the third term, and this is the fourth term. And so we want to come up with an expression of how do we figure out which number goes in that slot based on which position in the sequence it is. And so here I've just made a simple one where it just goes, it's just that number. You know, the first term gets a 1, the second term gets a 2, and so forth. But here we want to define that n is going from 1, 2, 3 up until 4. So it's the set of the first 4 positive integers, and it gives us this finite sequence. We can come up with an infinite sequence, which an infinite sequence, it will not stop anywhere. And so this one, the domain is just the entire set of positive integers. So it's all the numbers 1, 2, 3 counting up to infinity. So we can make the same sequence, which what if we made a sequence that went like 2, 4, 6, 8, going like this one, just up into infinity. You can see that always the number that's in a particular term, like the first term is a 2, the second term is a 4, so we're taking which term it is, which is n, and we're going times 2. So 2 times n, or else you could just write 2n. That is going to be an infinite series as long as we're allowing that n can either be, we can write this here a couple of different ways, but I'm going to write it that n comes from the set of natural numbers, which that's what this set is. Positive integers and natural numbers, they're the same thing. And so the set of natural numbers, that is the domain for this function. And so we're able to have this kind of a description of a sequence as a function, or else sometimes we would define, instead of calling it f of n, we would just give a definition of what is the nth term, and then you just plug in something else for n. So you could say like, well, what is going to be a sub 1? That would be the first term. I'll say this is the first term, a sub n. This is going to be the nth term. And so we can define the sequence also just based on what is the nth term. And so we want to find the first 4 terms over here. It would go, well, we want to find a1, basically a1, a2, a sub 3, and also a sub 4. We want to find these 4 terms. And for these, you're just plugging in this number down here. This is like where the n was. You're plugging that in for n, so it would go 1 squared plus 5 would be that number, and then the next one would be 2 squared plus 5, and then 3 squared plus 5, and then 4 squared plus 5. Those would be our 4 terms there, and we can get these ones. 4 plus 5 is 9, and then 9 plus 5 is 14, and then 4 squared is 16, plus 5 is 21. So we would get these 4 terms. And then we can have a little bit of a funny one here. We're taking a negative number to the nth power. This would give us something, whenever we do it, notice if you go with an even n, then negative number to an even power will be positive. And then if it's odd, an odd in for that one, if you take a negative number, you raise it to an odd power, you will get a negative number. And so every term for this one, every time you go even, odd, plugging in different ends, we will get a different sign. We will get alternating positive and negative. And so let's see what will happen here actually. We'll just get the first four terms and then we'll talk about what this means. But if we go A1, A2, A3, A4, those are the ones that we want to find. And then we're plugging in different numbers for n. So it's going 3 times negative 1 to the first power, negative 1/3 I should say, and then 3 times negative 1/3 squared, 3 times negative 1/3 cubed, and then 3 times negative 1/3 to the fourth power. Here this is going to go 3 times negative 1/3 is just negative 1. And then whenever we do this one, it's going to go, how is it? It's going to be negative 1/9 here. But it's squared, so it will be positive 1/9, so it will become 1/3. And then this one, it's going to be, do you see the pattern that we're getting? It's going to go negative 1/27, and then the 3, so it's going to go negative 1/9. And then this one will be positive 1/81 because it's to the fourth power, and then 3, so it will go 1/27. And so here, we would call this one an with an L there, alternating sequence. It's alternating because the sign alternates. And so how it goes negative and then positive and then negative and then positive is an alternating sequence. And so we'll have those coming up sometimes. That's really going to do it for this video. We will meet up in the next video. We're going to continue talking about sequences. We will introduce the idea of series as well. And then we'll wrap this up. And we will be done with chapter 8 as well. So thank you guys for watching this video, and I'll catch you in the next one.